All right, number 5, it says the function is positive and negative on the given interval. We're going to sketch the function. We're going to approximate the area bounded by the graph of f on the x-axis using left, right, and midpoint Riemann sum with n equals 4. We're going to use the sketch in part A to show the intervals of pi over 2 to 5 pi over 4 make a positive contribution to the net area. All right, so we're going to use technology to help us with each of these steps. So let me get our function so I can see it whenever I flip to the calculator. Fx is equal to sine of 2x, and we are bounded by pi over 2 to 5 pi over 4. And when I look at the graphs, our viewing window is going to be restricted from 0 to 2 pi, and we can just have it count by pi halves. All right, so I'm going to go to the little calculator, shrink it down a little bit. Y equal, we're going to open parentheses because I'm going to do a restriction. It's going to be sine of 2x. All right, and then if I graph it just here, you see the whole thing. Okay, I'm going to go to window. I'm going to change the x minimum to 0 and change the maximum to 2 pi. So I'm going to say 2 second pi. So I get a smaller viewing window. My y minimum, let's just say -2. I think a little bit more than what we need to see, and +2. So graph it, and you get to see a little bit different part of the window. Now I'm going to go back and add my restrictions. So I already have it encased in parentheses. Add another closing. We're going to do divided by, and then we're going to open parentheses, and we're going to say pi over 2 is going to be less than or equal to x. So 6. And then second, math, logic, and then x is going to be less than 5 pi over 4. All right, now if we graph this, okay, we get just a small piece of the function, and then this will help us identify the correct graph. All right, so our function goes here. That looks good. That's the only one that has that shape. All right, so A would identify our graph. All right, now it says use a calculator to approximate to get the approximate area. We're going to use the left Riemann sum. And so again, the formula was summation. Okay, for left, it is summation. Okay, equals 1 to n. You're going to do f of your function with the special x value. And that x value for left Riemann sum is times the change in x. Don't not forget that. Time changing x. And then the special x value, xk star, is equal to a, and then it's plus k minus 1, and then this is times the change in x. Okay. So let's find the change in x. So I got to do 5 pi over 4 minus, I'm going to write this as a 4, so it's going to be 2 over 4, same as a half. 2 pi over 4, and this is going to be divided by 4 because n is equal to 4. So this gives me 3 pi over 4 divided by 4. Keep, change, flip, so you'll get 3 pi over 4 over 16. 3 pi over 16. when you do keep change flip. So 3 power 16 is going to be my change in x. And so now that we have all the information that we need, I'm going to go back here. I'm going to go second quit, go to the home screen. We're going to do our summation. So math 0. And then we're going to use the variable x 1 up to 4. N equals 4. And then we're going to do our vars. We're going to get y vars, arrow over, and then function, and then y1 because my equation is in y1, and then open parentheses, and we're going to tell it what to plug in for x. So that's going to be this case right here. Now the a is the starting value, so that is pi over 2, and then plus, we'll say x minus 1 times the change in x, which is 3 pi over 16. Okay, so this is going to give me my left Riemann sum. So we're going to say pi divided by 2, and then plus, and then I'm going to open parentheses again, it's going to be x minus 1, and then close, and this is going to be times 3 pi over 16 times 3 pi divided by 16. All right, so this is going to be my left Riemann sum calculation. We get a negative, I'm sorry, I didn't multiply by the change in x at the end. So let me do this again, second enter, times the change in x, because you got your y value times the base. So we got to do times another 3 pi divided by 16. Okay, so we get negative 0.735 or 0.74. Round the final answer 3 decimal places. Okay, so that's 0.735. So negative . All right, now we want to approximate the right Riemann sum. Okay, so again, the right Riemann sum, it's similar. We're just going to have, so the kx is changing. The basic formula is the same. The x star is equal to a plus the k times the change in x. Now, all we're doing is getting rid of the minus 1, only difference. So I'm going to pull up, I'm going to recall the same function we just did. So I'm going to say second and then enter. It will pull up the same equation. And I'm just going to go back and delete the minus 1. Delete, delete. So I just get rid of those. If you hit clear, it will clear everything out. We don't want to do that. All right, so the right Riemann sum is negative 0.146. I said 416146. Let me make sure I read that right. Negative 146. Negative 146. Okay. All right. And then we're going to use calculator to approximate the midpoint. So the midpoint formula, the midpoint changes the x value. The midpoint is a plus, and then it is k minus a half, and then times the change in x. Okay. So if we want, we can go back to the original. I guess it'll be this one because I got my change in x in it. Go to this one, hit enter, and it'll recall that one. And I'm just going to add a divided by 2 right here. So the x minus 1 I'm going to say second and INS for insert, the delete button, add divided by into. If you don't do the second insert, it'll just type over what you have there, and you'll have to finagle a lot more to get that in there. All right, midpoint, we get negative point 0, sorry, negative 0.530 or negative 0.53. All right, so that's good. Now it says, which intervals of this make a positive and negative contribution to the net area? So if we look at our graph, okay, we can see that after pi, so from pi half to pi, we're getting negative, and then from pi to the end, we're getting a positive contribution. So based on that image, we can determine what part is positive and negative. So from pi half to pi should be negative. It says pi half to pi positive. Oh, positive from pi to 5/4, so that looks good, and then negative on pi half to pi. So that's what we noticed from our visual.